Okay, good afternoon, everyone. Sorry about having to do this. My stupid little pen broke, and I don't have a backup pen. I have another one for my setup at home, but these are not compatible. These aren't the same type of pen. So, anyways, I had no choice but to do it this way. So yeah, let's get down to it. So I gave you these problems last time. How did y'all do with these? Are there any questions on these? Do you want to go over any of this?
Can we go over number 4? I totally forgot how to do that one.
Yeah, four's a tough one. I really hadn't shown you one like this, so it's I was kind of seeing, what you could do on your own. While we're doing it, let's see. Yeah, okay, we'll start with 4. I think 4 is the hardest, so we'll do that one first, I guess. All right, so the idea here is to you have to understand what these decimals mean. Remember that the first position to the right of a decimal point is how many tenths you have. This is how many 1/100ths you have, how many 1/1000ths you have, and so on and so forth. So because my pattern repeats 2, 5, 2, 5, 2, 5, what I'm going to do is kind of write it like this: 0.25 plus 0.0025 plus 0.000025 plus, I'll do one more, 0.00000025 plus, and then this keeps repeating. Does that make sense? That if you started to put these together, you would get back this up here? That all clear to everyone?
Yes.
Yes. Okay. Now let's rewrite each of these as fractions. This is, let's see, 25, and we're in the hundredths position, right? The hundredths. So I'm going to write this as 25 over 100 plus. Now this is 25. Let's look at the position: tenths, hundredths, thousandths, 10,000ths. So I'm going to put 25 over 10,000. And then the next one will be 25 over, well, I just have to add another 2 zeros because that's what's happening here. Every time I move to the right, I'm going to have 2 more zeros in the denominator. So that'll be what, 1 million, 25 millionths. And then I could keep going. I'll do one more here, 25 over, I'll have 1 with 8 zeros. There we go. And then it just keeps going. So far, okay? See how I'm starting to turn it into something more like what the first 3 problems were, right? So now I'm going to try and get this. I'm going to realize that this is the same as, okay, this is 10 squared. This is 25 over, this is 10 to the 4th power. And so basically I'm just counting how many zeros are here, and that's the power of 10 I have. So 25 over 10 to the 6th power plus 25 over 10 to the 8th power, and then it keeps going. Any questions on that part? We're all happy? Or happy, content at least? So I'm going to now try and turn this into a sigma notation, all right? Because the whole idea here is to try and get this to look like this geometric series. Sum n equals 1 to infinity of a times r to the n minus 1. And we talked about in class last time that this sum will add up to be a over 1 minus r, okay, if the absolute value of r is less than 1. So right now, we should be able to write this as a sum. N equals 1 to infinity. Now notice that all the numerators are always the same, right? We always have 25, 25, 25, 25. So I have a 25 in all of these. So that means my formula should have a 25 in it. And then can somebody tell me what the denominator needs to be? They're all powers of 10, but raised to even numbers. So how do I create the list of even numbers? Got to go back to class from before Thanksgiving, I think.
Is it 10 to the power of 2n?
2n, yeah. So remember when we were doing this, when we first started doing this, we were like, oh, how do we create these lists? And this right here created the even numbers. 2n creates 2, 4, 6, 8. And it starts at 2. And that's what we need here. Where is this? Where am I? Yeah, so we want to have 10 on the bottom. Good, whoever said that. 10 raised to the 2n. All right. So this right here, what we've done is we've taken this repeating decimal and we've rewritten it in sigma notation, in this sum notation. So now my goal is to see if I can get it to look like this over here. A times r to the n minus 1. So this is going to be the tricky part because, again, I haven't really shown you a lot of this. So watch and learn. Okay, so first thing I'm going to do is I'm going to rewrite the 10 to the 2n on the bottom. Watch this as 10 squared raised to the n. Now I'm doing that because that's property of exponents. If we have x to a power and then to another power, we multiply the powers. So what I'm doing is I'm doing this property backwards. I have 2 times n, so I'm rewriting it as 10 squared raised to the n. If we multiply these together, we would get 2n. So that's not a very natural step, but it is correct to write it that way. And the reason I did that is because of this. Now I can just rewrite 10 squared as 100 to the n. Right, so I just squared the 10 and got 100. And now I'm starting to get it closer to this. I'm going to do something else now. I'm going to take the 25, pull it out front, and I'm going to rewrite this 1 over 100 to the n. I'm going to put it like this, just separate it from the 25 with multiplication. And here's another critical step, is just to realize that this is the same as 1 over 100 to the nth power. So think about this. If you have 1 over 100 to the nth, that's the same as having 1 over 100 to the n, because if you apply the n power on the 1 and on the 100, of course, 1 to any power is itself. So that would become this, right? That's this. And so 100 to the n on the bottom, this is good. This is an equivalent expression. Y'all still there? Still with me?
Yep.
Okay. Do y'all see it starting to come to life here? I have a number in front. I have r to the n minus 1, but see, I don't have minus 1 there. Do y'all see that? I don't have n minus 1. So this I did do last class. Do you remember what I did to make it be an n minus 1?
Added 1 and subtracted 1.
Yep. Now I'm going to do it a little different. I'm going to subtract the 1, then add 1. It doesn't matter which order you do it in, but I'm going to do it that way because then I'm going to kind of group these first two together. So I'm going to do this now. We're almost there. Sum n equals 1 to infinity of 25 times, this becomes 1 over 100 to the n minus 1 times 1 over 100 to the 1. So again, this is using property of exponents backwards. I'm using the fact that I have exponents that are being added together. It's almost like I'm doing like these two plus that one, and I'm splitting it into two factors. Now I have the n minus 1. 1 over 100 to the 1 is just 1 over 100. And I'm going to move this out underneath the 25. And when I put the 100 under the 25, it reduces to become 1/4, then 1/100 to the n minus 1. And I am there. I have arrived. I've arrived because my goal was to try and get it to look like something like what's here in the yellow. Trying to get it. So for me, I can say that my A is 1/4. And I can say that my R is 1/100. And notice that if you take the absolute value of this, it is less than 1. And since it's less than 1, we know that there's an answer to this. The answer is that this sum adds up to be A over 1 minus R. So for us, A is 1/4 over 1 minus R, but R for us is 1/100. Y'all still with me? One-fourth over, now here I have to get a common denominator, so I'd probably just rewrite this as 1/1, multiply top by 100, bottom by 100. That way I can subtract these two. I would get 100 minus 1 over the common denominator. So I get 1/4 over 99 over 100. And then I multiply, so I'm dividing by a fraction, I'll multiply by the reciprocal. And there's one more thing we can do and we're there. Just reduce that. 4 goes into that 25 times. And now just multiply straight across and you get your answer. 25 over 99. So if you get on your calculator right now and you type in 25 divided by 99, you'll get 0.2525252525 forever. What do y'all think? That's a lot of work, huh? That's a lot of strange stuff happening here. How about either of the other two? Do you want to talk, or the other three? Any of these you want me to talk about? Did I put a problem like that on your review? I sent out this review yesterday, day before. Yeah, I did not put a decimal like this on the review. So if I do give you something like this, it would be a bonus question. But problems like 1, 2, and 3, that is fair game for the test. All right, so what would y'all like to do today? We have a review. I'm happy to work problems from the review. I know you haven't had the review for a long, long time, but maybe you've had a chance to maybe look over it. Is there anything in particular you'd like for me to go through? Or would you like me to just start working it out? Or do you want to work on your own? I mean, today is your day. You tell me what you want to do.
Can we work them out?
Sure. Sure. Do you want me to just start at the beginning, or do you want to like pick the ones? I don't know. We should have enough time to get through it, but we might not.
I think we can do at least one problem from each section.
That's what I was thinking. I would let y'all pick, like, okay, like for number 4, you want me to do A or B, or like number 5, maybe I'll do 2 of these. That to me sounds like a good plan. That sound good to everyone?
Yes.
Yeah, okay. Let's start at the beginning here. So what I did, if you look back, what I did here is I looked at the material that we have. I'm only looking at material since our last exam, because remember, we didn't do an exam, right? We said we'll make the final We'll take the highest grade out of all your tests to replace that third exam. So I didn't want the final exam to go out all the way back. So I started from the last test, and I just kind of went through the homework assignments and through the lectures, and I kind of picked some problems that weren't necessarily homework problems. I mean, they were like the even problems. I asked you to do the odd ones. And so that's why there's a bunch of copy paste here. This is all stuff problems that you've seen, at least in the homework assignments. They've been in that set of problems. So, all right, so first one, draw the inverse of a function. So how do I do this? How do you draw the inverse of a function?
You reflect it over the identity function.
Yeah, you reflect it over the identity. So what I'm going to do is I'm going to try and draw this blue graph reflected over this black line. Now that might be a little hard to do. I don't think I can rotate this. I can't rotate it freely. So I think I'm just going to have to do my best. I'll just kind of turn my head to the side and do it. I'm going to try and I'll start here. I'll make a little reflection. So I'm reflecting this little part here. And then try and, oh my gosh, it's terrible. I'll start over. Reflect here, still bad. And then just kind of make it go like this. And then a reflection here. And then like that. So the whole key to that problem is just to realize that anytime you look at a function and its inverse, they're reflections of one another over the identity. So you do your best. It won't be perfect, but it should look pretty close to a reflection. Okay. Now, number two, I give you two functions, f and g, and I ask you to show two different things. You have to show that this is true. First thing you have to show, and then the second thing, you have to show this is true. So in other words, if you put these together with composition, f of g of x, at the end, you just get x. So I think what I'll do is I'll do one of these and I'll leave you to do the other one. So I'm going to do the first one. I'm going to try and show this is true. Oops. Sorry. So the first one, I'm going to try and show that f of g of x is x. So first I write down f of g of x. Now that means I'm going to take f, and inside of it, I'm going to plug in g, which is 4x minus 3 over 2 minus x. And now I'm going to take all of this, and I'm going to take that whole expression, and I'm going to replace it into the f function wherever I see this x. So this is going to be a pretty complicated looking thing. It's going to be 2. That's this 2 right here. You know what? Give me just a second here. I don't know what's been going on with my computer lately. Where the hell is my control panel? Where did it go? There we go. Yeah, it's weird. Those my yellow cursor keeps going away. Okay, so this is this 2 right here, and now I have the x, but the x is this thing. So I've got this big ugly thing here next to the 2, 4x minus 3 over 2 minus x, and then I have plus 3, and then all of this over x, which is the 4x minus 3 over 2 minus x, and then plus 4. Okay, so that's the initial part. That's plugging g into f. And now I have to clean this up. Okay, it's going to be ugly, but I'm going to clean it up. So I'm going to distribute the 2 through the top there. So I get 8x minus 6 over the denominator 2 minus x plus 3. And then on the bottom, I have 4x minus 3 over 2 minus x plus 4. Now, there's a couple of different ways to approach this now. The way that I suggest you do this is to take your top and bottom and multiply by the denominator 2 minus x. You're going to do it on the top and bottom in and distribute it through. So you're going to distribute it here, and then you're going to distribute it here and here. So when we distribute the 2 minus x to this first one, what happens? When we distribute it to this one, what's going to happen?
It cancels the denominator.
Yeah, the denominator cancels. So all we're left with is the 8x minus 6. Then plus, now when we do it times the 3, now that nothing cancels. So we get the 3 times the 2 minus x. But see, that's all that's left on the top. We got rid of that complicated looking fraction. And then on the bottom, same story. When we distribute it here to here, the 2 minus x cancels. We're left with the 4x minus 3. And then again, that 4 gets hit with the 2 minus x. We have to do that maybe on the next line. And I keep going. So I have 8x minus 6 plus, I distribute the 3 through, 6 minus 3x. And on the bottom, 4x minus 3, I distribute the 4 through, plus 8 minus 4x. And if things are right here, a bunch of things cancel, we should be good here. Let's see. This cancels, this cancels. I just get 5x up top. And on the bottom, the 4x and the 4x cancels. And then the 3, negative 3 plus 8, that gives me a 5 on the bottom. And now the 5s cancel and I get x, which is exactly what I was wanting to show. So I've done the first part. The second part is the composition the other way around. That's where you start with g on the outside and you plug f into that. Y'all feel okay about that? Should I proceed or?
Yeah, I feel good.
Yeah, everyone all right? So the way I would use this review, of course, go through the review. But what I would do is I would look at this problem, okay? After you've done the review, if you want to study more, go back to, you know, our classes, our lectures, and let's, you know, look at where that was. Like, where did I talk about this? Hold on. I believe this was in October. Yeah, this was number 41 right here. So, you know, you might want to go back and look at your assignment and be like, okay, maybe I'll try a couple of these just to make sure I'm comfortable with this. That's the way I would look at the review, is to go back after you've done the review, go back and find other problems similar to it in your homework and study those. All right, so for the next one, we're supposed to find the inverse of one of these functions. So let's see, we'll do a poll. So for this one, I just want to know which one y'all want me to do. Let's say choice one is A and choice 2 is B. It's not like there's a ton of y'all in here, but at least I'll give y'all the opportunity to choose. Okay, most of y'all want me to do the second one. All right, so we want to find the inverse of the function. So we first have to look at this function, understand what's going on. We have a function is defined to be x squared plus 9, and then very important, they're restricting our domain. We're only looking at this function when x is greater than or equal to 0. All right, so to find the inverse, we have a standard set of steps. The first thing we do is we take this, we replace the f of x with y. And then next step is we switch x and y. So we put x wherever y was, we put y wherever x was. And then the next thing we do is solve for y. So I'm going to go about trying to get y by itself right now. I subtract 9 on both sides. And then I take the square root on both sides. Now, when I take the square root, I have to do plus or minus. And this is y. And then now we replace y with f inverse of x. And this should be your inverse function. But we have a problem because there's two answers, right? There's the plus and the minus. So which one is it? Is it the plus or the minus? And why? Think about it this way. Think about it this way. If I look at these things from a picture, the original function f, okay, I'm talking about that one, right? It only takes positive numbers in, doesn't it? It only takes positive numbers in. That's what this says here. So I'm only allowed to plug in x values bigger than or equal to 0. And then it takes those things and it spits it out over here and you get whatever numbers are here. Okay, we don't know what they are. Whatever they are, we've got numbers. I just know that you can only plug in positive numbers. Now the inverse function goes back and sends this back, right? So what can you tell me about what comes out of this function, this inverse? What do these things have to, they have to be positive, right? They have to be positive numbers. Well, they could be 0, but they can't be negative. So that tells you right away that, look, this right here, we want to throw away the negative one. We only want the positive one. So the inverse function needs to be the positive square root of x minus 9. That's it. Now, just so you understand this, and I make sure you understand this, had the problem originally not been this, had the problem been this instead, okay, had it been this, then we would have picked the negative one, because the domain of the original function would have been negative numbers, so we would need the inverse function to be spitting out negative numbers, and that means we would want the negative square root. We good? Okay. All right, let's see what's next. So we got this. I'm going to highlight the ones we've done. So I did this one. I did this one for this one. I did this one. All right, so use transformations to graph each function, determine the domain, range, horizontal asymptotes, y-intercept. So let's do I think we should probably just do these both. They're not hard. Give you an idea of what I want for these. I don't want you spending a whole lot of time on the test doing these. All right, so for part A, I want you to graph that. All right, so I don't want a detailed graph. All I want is for you to give me a basic idea of what's going on here. So for this, you need to know that it's an exponential function. And it's exponential growth because this base number is bigger than 1. So you know that it looks like this. Okay, and we also know that this goes through the point 0, 1. And then what does the +2 up here in the exponent do to that graph? What does adding 2 inside the function do?
It makes it move to the left.
Left 2, exactly. So we need to take this red graph and just move it to the left 2. So I'm going to grab that point. I'm going to pull it over here to 2. Now, this will be my real answer here. So this red one is like, this is what 2 to the x looked like, okay? So the black answer is going to be what happens when I move it to the left 2. And then everything else just kind of, you know, do your best. So what's the domain of this? This is 2 to the x plus 2. What's the domain?
Negative infinity, infinity.
Everything, right? Yep. Negative infinity to infinity. Good. All right. What's the range of this?
The same thing.
From 0 to infinity, but
0.
not including infinity, 0.
0 to infinity, right? We never actually hit negative numbers, right? So we never get any negatives and we never hit 0. We don't have an x-intercept, right? So we have just from 0 to infinity for range. Horizontal asymptote. So what's the horizontal asymptote?
0.
It's y equals 0. Exactly. So the horizontal asymptote is going to be, you could say the x-axis if you want. If you want, that's fine, x-axis. Or if you want, you can put y equals 0. Those are the same thing. It's a horizontal line. All right. The only thing we don't have is the y-intercept. I need to know where this hits right here. Well, can you tell me where how to get the y-intercept?
Don't we plug in 0 for x?
Yep, just plug 0 into the function. Good. So just plug 0 in. If you plug 0 in to the function, you will get just 4. So the y-intercept is the point 0, 4. That's this point here. That's it for part A.
We got 4 because it was 2 square, right?
2 squared, yes. This is
Okay.
2 squared. Yep. All right, now for the other one, we still have exponential growth. Okay, so in the beginning of this, we should know that this looks like this. This is what 3 to the x looks like. But we have a negative in front. So what does a negative in front do? Reflect over the x-axis, right? So this gives me a reflection down here like this. This is now 3 to the negative x. So now I'm hitting here. So this is actually 0, -1. It used to be, started out as 0, 1, got reflected over. And now I need to add 1. So what does adding 1 to this do?
Moves it up 1 unit.
The whole thing goes up 1. So this point that's here now moves here. And what used to be the horizontal asymptote, right? This used to be the horizontal asymptote. That all gets moved up also. So I know my graph is going to get closer and closer to that. And then on the right side, it just keeps going like this. So this is my -3 to the x plus 1. Domain, still everything, right? You can draw this picture to the left and to the right. What about range? This one's a little harder.
-infinity to 1.
Negative infinity, good, to 1, not including 1. You never reach it. So this graph goes down forever, and you come up and you never quite reach 1. You get closer to 1, but you never reach it. Horizontal asymptote?
+1.
Y equals +1. Now make sure you put y equals on the test. Don't put just 1. Don't just put the number 1. You need to, y equals 1 is a horizontal line. X equals 1 is vertical. So we have to be very specific. We're talking about a horizontal line. And then we need the y-intercept. I think you can tell the y-intercept just by looking here. But it looks like it hits at 0, 0, right? All you'd have to do is plug 0 into the function and you would get that. Give me just a moment here. Okay. Questions? All right, so on this next one, take a look at them. You pick your top 2. Choice, oh wait, hold on. I want to relaunch the poll, but I want to. Oh, there it is. Okay, there we go. So you pick the 2 you want. Choice 1 is A, choice 2 is B, choice 3 is C. Pick your top 2. I don't know, is the poll letting you pick more than once? It may not be. May
No,
not
it's just one.
Only once.
No, that's okay. So pick your top, everyone pick your top one first, the one you want to see. Okay, so most of you want to see choice 3. That's good. Okay, now pick your second choice now. We're gonna do number 3. Pick either 1, 2, or 4. We're taking so much time on the poll, we've probably done them all already. All right, that's good. So it looks like most of you want 2 and 3. So the second one, the third one. I'm surprised no one wanted the last one. Or not many of you wanted the last one. Okay, this one, let's do that. We're supposed to solve for x. 5 to the x plus 3 equals 1/5. Now look, there's multiple ways to do this. There's an easy way and there's a hard way. Let me do the easy way first. The easy way is to realize that the left side is a power, is 5 to a power, and the right side is also 5 to a power, right? 1/5 is the same as 5 to the -1. And since both the bases match, that means all we have to do is make those two match, which means you just put x plus 3 equal to -1, and then subtract 3 on both sides, and you get -4, and that's it, you're done. That's the easy way. And it only works because both of the bases were 5. The harder way would be to be like, okay, I'm trying to solve for x, it's up here, so I need to get it out of there, so I'm going to bring in the log, and I'm going to do the little loop. So I know my base is 5, and then over on the right side has to be x plus 3, and then here has to be 1/5. So that way the loop matches up with the equation. 5 raised to this all look familiar? Equals this. And then what you do is on the left-hand side, you use your change of base formula, and you convert that to natural log of 1/5 over natural log of 5 equals x plus 3. And then you use your calculator. So natural log of 1/5 on my calculator, then divide that by natural log of 5. And on my calculator, it does tell me that this turns out to be -1. Now you might get a decimal, like really close to -1. Maybe you'll get like -0.9997 or something. Go with whatever you get on your calculator. Subtract 3 from both sides, you get -4. That's the harder way. That's the more tedious way. Got it? Now this one, same thing. There's an easy way and a hard way. The easier way is to realize that both of those numbers, 9 and 27, are powers of 3. Okay, they're both powers of 3. This is 3 squared raised to the -x plus 15. And this one is 3 cubed raised to the x. And then what we can do is we can multiply the 2 times this power and then the 3 times that power, and it comes up, we get a new equation. I'm gonna just try and, I'm out of space, so I'm just trying to squeeze it in here. If I multiply the 2 through here, I get 3 raised to the -2x plus 30 equals, and then the other side I get 3 raised to the 3x. And just as the previous problem, they both have a 3 down here, which means we just have to match the exponents up. So I've just got to go solve that little equation over here. -2x plus 30 equals 3x. I will add 2x to both sides, and I will divide by 5 and get an answer of 6. So on the test, what I would be doing is I would be looking to see if there's something that all the numbers have a common base of. If they don't, then you're going to have to use the logarithm and stuff like that, like we did before. Real quick, I won't do the problem, but this one right here, I would start this off by rewriting this as 3 squared to the 2x. Then I'd rewrite the 27 as 3 cubed to the x squared. And then the other side is 3 to the negative 1. And then I would start putting this together. I'd multiply those together, multiply those. And then because these are being multiplied, I would add those two exponents together and then make it match the other side. All right, let's keep going. I'll let you choose again. So A, B, C, D, which one do you want? All right, so we're going to do the fourth one. We're going to do the fourth one. I'm going to relaunch the poll. Fourth one we're doing. Which other one do you want to see? All right, we're doing the third one and the fourth one. That's what the vote is established here. So let's do the third one. All right, so here we have a log equation. Log base 6, 36 equals 5x plus 3. Wow, okay. Well, man, there's a couple of ways to do this problem. Again, there's a hard way and an easy way. Does anyone see the easy way? Can somebody tell me what this is? What is that really asking you?
6 to what power equals 36?
Yeah, 6 to what power is 36? Well, 6 to what power is 36?
2.
2. So this is just 2 equals 5x plus 3. And so now you just subtract 3 on both sides and divide by 5. And you get your solution. Now, another thing you could have done is on this side, you could have done on your calculator natural log 36 over natural log 6, and you would have gotten 2. So I think that one's actually kind of too easy. I'll do A after I do the last one. This one right here. Okay, so we want to solve e to the negative 2x plus 1 equals 13. Okay, there's nothing that I can do here. Like I can't rewrite 13 as like e to some power or anything like that. So I'm gonna have to go to the log here. I'm gonna write log base e. Then on the right side, I'm gonna put the power 2x plus 1. And here I'm gonna put 13. And then just remember what log base e is, right? Log base e is actually the natural log. So I'm just doing natural log of 13 equals negative 2x plus 1. And then get my calculator. I'm going to do natural log 13. That's going to give me 2.565. Let's just say 565 is equal to negative 2x plus 1. Okay, I subtract 1 from both sides. And then I divide both sides by -2. And I should get -0.782 about is what x is. Questions?
Why didn't we put E again?
Why did I put e?
No, why didn't we? It was natural log 13. Why didn't we put natural log? Because it's like because E is the natural log, right? So
Yeah, because that's what, whenever you have a logarithm with base e, that's what the natural log is. Now, your other option would have been to do this on your calculator, natural log of 13 over natural log of e. You could have done that, but it turns out that natural log of e is 1. So it's the same as just doing natural log of 13.
oh, okay, thank you.
All right, let's look at the first one. Log base 3 of 3x minus 2 equals 2. We're solving for x. So to do this, I'm just going to go to the loop. I'm just going to do the little loop on this. So this means 3 squared, not 3 times 2. 3 squared must equal 3x minus 2. And that means 9 must equal 3x minus 2. And then that's a linear equation. I'm sure you can solve that. Add 2, divide 3, and you're done. Oh. All right, how are we doing on time? We're good. Oh, hold on a second. All right, sorry about that. All right, how about this next one? Things are starting to get interesting now. What do you think? Let's forget the voting. Just tell me which ones you want. First come, first serve.
So we do B.
B? Is that what you said, B or D?
Yes, B as in boy.
B? Okay, which other one do y'all want to see?
C.
You want to do B and C? All right, let's do, I'm going to go to a different page just in case I need more room. So for B, B's a little weird. 2 log base 5 of x equals 3 log base 5 of 4. All right, so notice that these both have the same logs on, this same base for both logs. So if we can just get the insides, we could just match the insides. The problem is we have a 3 here and a 2 here. So what I'm going to do is I'm going to use a property of logs that allows me to force this into here and make it a 2 up here. So it becomes log base 5 of x squared. And then I'm doing the same thing over here. I'm going to force this up here. This becomes log base 5 of 4 to the 3rd power. And now that we have the same log, same base, all we have to do is set the arguments equal to one another, and we will have a solution. So we set these equal, and that means x squared must be, let's see, 464. 4 times 4 times 4. And then take the square root on both sides. And when you do that, you should get plus or minus 8. Plus or minus 8, because you take the square root on both sides, right? Which answer? Do we keep them both, or is it only one of them, or none of them? Look at your answer. Look at 8. Can you plug 8 in here for x?
We only keep the positive because you
Only
can't
the
plug in a
positive.
negative.
That's right. We can't plug this negative into this log because logs are not, you're not allowed to plug negatives into logs. So the only answer we have here is that x is 8. All right, that's that one. And the other one, we have log base 5 of x plus 3 equals 1 minus log base 5 of x minus 1. All right, we cannot do the same thing we did here where we try and set the insides equal to one another. Can't do that because this 1 right here is causing an issue. So what I'm going to do is I'm going to bring all the logs to one side first. So when I add that, it's a negative log on the right side. So when I add it to both sides, it turns into a positive log base 5 of x minus 1. And then this is the critical step. We can use property of logs to condense that into a single log. But inside this log will be these two things multiplied together. So I'm using a property of logs that said if you have log base anything of x plus log base anything of y, it turns into a single log base anything of x times y. That's the property I'm using here. And that must be equal to 1. Now what? You'll know what to do?
Sure. So with a cycle, would that be 5 to the power of 1?
Yep.
Equals- Oh, okay.
There we go. That's it. We're going to do that little loop. We're going to do 5 raised to the first power must equal the x plus 3 times x plus 1, or x minus 1. 5 to the first power is 5. And then we have to FOIL this out on the right-hand side, and we should get this quadratic. And now we have to solve the quadratic equation. So we need to move everything to one side. So I'm going to subtract 5 on both sides. And that gives me minus 8. And then I can either use the quadratic formula or I can factor. And this does factor. This factors here. And so I set each factor to 0. I get 2 solutions. I'm not showing the work there, but I'm trusting you can set those equal to 0 and solve. We get -4 and 2. I have to check my answers. So -4, I cannot plug in because I'll get negatives in here if I plug in -4. So throw that away. And then 2 plus 3 is 5. I can do that. 2 minus 1. Yep, that's good. So I should have just the solution. Okay. All right. First come, first serve on this one. Number 8.
Do A.
A. Okay. And what else? No other requests? Yeah, I have no idea. How do we do this? This is weird. What in the world do we do? So if you're trying to solve for x and x is up in the exponent, it's useful to bring the loop in, right? To try and do the loop, bring the log in. So let me try this log. if I try the log, I can either use the base of pi or the base of e. I'm going to use base e. Watch. E. Now let's make the loop. What is e being raised to? Well, x plus 3. So that's going to go on this side. And that must equal the other side of the equation, which is pi to the x. And then you look at this, you're like, well, wait a minute, I still have an x up here, right? But what can I do with that x? Because I have a log now, what can I do?
And pull it outside of the log.
Pull it outside the log, you drop it out front. So I can pull the x out here times log base e of pi equals x plus 3. And we were just talking about this a moment ago. Log base e is really the natural log. So this is just x natural log pi equals x plus 3. Now let's go ahead and do natural log of pi on our calculator. You get about 1.144, something like that. So this can become 1.1. I'm going to round it to 1.145 x equals x plus 3. Let's subtract x on both sides. We get 0.145x equals 3, and then divide 3 by 0.145. Ooh. I'm getting that x is approximately 20 point, let's just say 20.7. That's a good problem. I like that. Do we have any questions on that? Let me look at these two. I think D is the harder of the ones that are left. Well, B is kind of weird too. Let me do D. So in D, we did one like this in class. This is a problem where it's going to turn into, it's going to look like a quadratic, but we got to make it look like that first. So I'm going to first realize I can rewrite this 3 to the negative x as 1 over 3 to the x. And then I'm going to do this very nice step of multiplying both sides by 3 to the x to clear the fractions. And when I do that, I multiply here to here. I add the exponents. So x times x, I'm sorry, x plus x is 2x. And then when I multiply here to here, the 3 to the x cancels, which leaves me with negative 14. And on the right side, I get 15 to the x. Is that right? Is that right?
Yes.
Is that right? Do I actually multiply the 5 and 3 together?
No, it's not.
No, order of operations, right? You have to do exponents before multiplication, which means you have to leave it as 5 times 3 to the x. It's a common mistake. Students will do that and they'll go, oh yeah, it's 15. Got to leave it alone. Cannot do that operation until you do this operation, but you don't know what x is, so you can't do this operation. So I have to leave it. Now what I do is I bring everything to one side. And I put it kind of in like a descending order. I have 3 to the 2x here. This came to the left side, became negative. This was already here, equals 0. And now I'm going to make a substitution. I'm going to let u be equal to 3 to the x. Oh, you know what? I should point out this right here is 3 to the x squared. Yeah, you have to see that step before you can do the substitution. So now making the substitution, u is 3 to the x, you have u squared minus 5 times, this is u, minus 14 equals 0. Now you have a quadratic. I'm going to factor. If it factors, it does, I think. u minus 7u plus 2. And then finally set those two equal to 0. You get 7 as one answer, and you get -2 as another answer. And now you replace u with 3 to the x. 3 to the x is 7. 3 to the x is -2. Now the one on the right has no solution because you can never raise 3 to any power and get a negative number. The one on the left requires I convert it to a log by doing log base 3, 7 equals x. That's the loop. And the left side is natural log 7 over natural log 3. That's using the change of base formula. Then I just get my calculator and get an answer. About 1.77 equals x. Good. Questions? Let me see here. All right, which one of those do y'all want to see? 9 or 10?
9.
9? Yeah, 9's the harder one. Because 9, they don't, for 9, they don't give you the formula. You have to come up with the formula. So this one's a little easier. Hold on though. I feel like I know we did this. I feel like we did that problem exactly. Yeah. Carbon 14. Yeah, you know what? Just for the sake of compare these again. 30% of its carbon. Here it was 1.6%. So look, I think I've worked through this problem. I think I'm going to pass. It's a lot of work. I think I'm going to pass because there's a video 11:15. You can go back and watch this where I worked through this. It's quite a bit of work here. Yeah. All right, so what about these systems of equations? You have a choice of matrices. You can do these however you want. So you can do them with just the matrices, or you can do them, you know, leaving them with the x's and the y's and the z's. How do you think y'all are going to want to do it on the test? Do you care? Do you?
I'd probably use matrices.
Matrices? All right, let me just pick one of these. I'm just going to pick one randomly here. I'm going to do this. I'm going to solve this system, and I'm going to do it with matrices. So I've got to make sure that I've got all my variables on one side, that the x's are lined up with the y's, and I'm just going to write down the coefficients. So 3, 3, -1, and then here I've got 4, 1, and then 8/3. Okay, I've got a fraction, big deal. All right, my goal here is to do this. I want to get 1, 1, 0, and then I don't care what the numbers are here. I'm trying to get it to reduced, reduced echelon form, right? That's what I'm trying to get to. So how do I want to go about this? I'm getting burned out, if y'all can't tell. Okay, so only because I've been reviewing on every class, going through just problem after problem after problem. So I'm a little bit exhausted from doing math today. All right, so we go here. I'm gonna multiply this one by 12 and this one by -3. And that should give me a 0 here. I'll be able to add, replace that with a 0. So multiply that through my new matrix. My new matrix will be 12, 12, -4, and then the bottom one will be -12, -3, and then when I multiply this by -3, I get -8. And now I'm going to add these two rows together, which gives me a 0, and then here I get a 9, and here I get a -12. And then my first row, I'm going to go back to what it was, 3, 3, -1. And then on the next step, I'm going to get ones in both of these positions. So I'm going to multiply the first row by 1/3, and I'm going to multiply the second row by 1/9. And that should have the effect of turning this into a 1 and this into a 1. So now my new system will be 1/3 of that is 1, 1/3 of that is 1, and then 1/3 of -1 is -1/3. And then my second row is 0. I divide this by 9, I get 1, and I divide that by 9, I get -12/9, which can be reduced, but I'm just showing you what happened. And now, once you're here, you now know what y is. This last equation is telling you that y is equal to -4/3. And then you can go back up to this equation. This equation on top here now reads x plus y equals -1/3, but you can replace the y with -4/3. And then add 4/3 to both sides. And that should give you 3/3, which is 1. So x is 1. X is 1, y is -4/3. Now, if you wanted to use substitution or elimination and leave things x and y, that's fine. I'm just showing you how to do it with the matrices. All right, give me like 2 minutes. I need just to stand up and walk around for a minute. You do the same if you need to. All right. Here we go. Here's what I'm doing. I really am not in the mood to do the system of equations right now. Hey, stop. What's going on? There we go. I'll come back to this. This will be the last thing I do. Let's do these formulas. Maybe y'all can figure these out. Can anyone tell me the formula for the first one? Do y'all notice a
Is it
pattern?
2n minus 6.
2n minus 6. There you go. That's it. They jump by 2 each time. They keep adding 2, add 2, add 2. So we know we need 2n, and then it's just a matter of starting it at the right place. So we want, when we plug in 1 to get -4, so we have to subtract 6. Good. How about this one? It alternates, yeah? Negative, positive, negative, positive, negative. So -1 to what power?
In
wanna
plus or
start it.
minus 1.
And if you do n plus 1, then you're going to start out positive,
Yeah.
right? Because
so
remember,
negative
we're
to
going to
minus
start
1.
n at 1. We're always going to start n at 1 here, at least here. In
Yeah.
Cal 2, you can start n at different places, but here we're just going to start at 1. So we'll want -1 to the n. That should start us negative. And that'll take care of the negative sign. So don't even worry about those anymore. So look at those numbers. You see the common thing happening here?
It's 4n.
Yeah, they're just jumping by 4, right? So we want a 4n, and where are we starting at? 13. So when you plug in 1, you better get 13. So what are you going to have to add to this?
9.
9. There you go. Okay. How about this one? This one was a little harder. What the heck? Did I write this one down wrong? I feel like I wrote this down wrong. Uh-oh. Do you see what I'm saying? Because it's going negative, negative, then positive, negative, positive. I think I may have messed up. I think the first one's supposed to be positive. Yeah, because the new, yeah, so change this to positive. My apologies.
So,
So
negative
this-
1 to the
yeah.
n minus 1.
-1 to the n minus 1. You could do n plus 1, doesn't matter. Okay,
Then the bottom would be 7 to the power of n.
yeah, 7 to the, so notice on the first one, there's a 1 down here, right?
Yeah.
Which for us would have to be 7 to the 0, because this is 7 to the 1, this is 7 squared, this is 7 cubed, right? So that would have to be 7 to the 0. So when you plug in 1, you need to get 0. So what do you put down there?
N minus 1.
And -1, good. And then up top, forget the signs, forget the negative, positive stuff. 5, 8, 11, all that stuff, that's jumping by 3, right?
Yeah.
3n, and we want to start at 5. So add 2,
Yes.
that should do it. All right, so now this number 14 is a recursive sequence. So I tell you what the first 2 terms are, and then I ask you to find the 5th term. So I give you the first 2. Let's find the 3rd one. The 3rd one, according to this formula right here, should be -3 times the second one plus 4 times the first one. So all I did there is replace the n with 3, put 3 in here, put 3 in here. And I know what A1 and A2 are. So this is A sub 3 equals -3 times A sub 2 is -3 plus 4 times A sub 1, which was 4. So this is 9 plus 16 is 25. That's your 3rd term. So I know A1 was 4. A2 was -3, A3 was 25. These numbers are going to get big. All right, let's find the 4th one. The 4th one should be -3 times the 3rd one plus 4 times the second one. So this will be -3 times the third one, which was 25, plus 4 times the second one, which was -3. This is -75 minus 12, -97? No, 87. That's your fourth one. One more. The fifth one is -3 times the fourth one plus 4 times the third one, which is -3 times -87 plus 4 times 25. Just going to get my calculator here. I'm getting 361. Questions on that?
No questions.
No, you're good. All right, so this one here, I ask you to find the sum. This is a good one. So there were some special formulas that I gave you in class. There were 3 of them that I gave you. And I was talking about principle of mathematical induction. So these were the special sum, the finite sum formulas. If you're adding up 1 plus 2 plus 3 plus 4 to k, here's the formula. If you're adding up the sum of the squares, here's the formula, and so on and so forth. So for this problem, number 15, what you have to realize is that this is 3 squared plus 4 squared plus 5 squared plus 6 squared plus ... all the way out to what number squared? What is that? 1600 is what number squared?
40.
40. Out to 40 squared. Right? That's what you want to know. The formula we have, okay, the formula from last class, this right here gives you the sum. But notice it starts at 1, right? Like this formula here. It starts with 1 squared, 2 squared, 3 squared, right? So we are only looking for this part of it out to 40, which means we're only looking at this part out to 40. Which means that it means we can use this formula, but we need to subtract off the first 2 from here because it's not part of this sum. Following me?
Yep.
The formula will start you out at 1, but we need to really start at 3. So let's go ahead and do this. If we did the sum, n equals 1 to 40 of n squared, according to the formula, it should be whatever the k is. So 40 times 40 plus 1 times 80 plus 1, 2 times 40 over 6. So calculator time. This should be equal to 22,140. That's what would happen if you added 1 squared plus 2 squared plus 3 squared forever. We only wanted to go from 3 squared out, so we'll need to take away these first 2. So our answer here is going to be the 22,140, but then take away the first 2, which was 1 squared plus 2 squared, and then that will give us 22,135. All right, number 16 is a lot like the first problem we started in class with, where we had this this thing 0.252525, and we got it down and we got it down and we got it to this point right here. And we're like, okay, we got to make it look like this. Right? And so that's exactly what I need to do here. I need to see if there's any way that I can make this look like, here, let me put here. Can I make it look like this? Right, that's the goal. Can I make it look like this? So to do that, I'm going to notice a couple of things. I need n-1s. So I'm just going to come in here and I'm going to do this. I'm going to do -1 + 1 on the 2 to the n. And on the bottom one, I'm going to do -1 + 1 also. So let me show you what this turns into. I'm going to go to a new page. We can rewrite this as sum n equals 1 to infinity. I know that sum looked terrible. Let me see. And we have 5, and then I'm going to rewrite that 2 to the n as 2 to the n-1 times 2 to the 1. And then over on the bottom, I'm going to write it as 3 to the n-1 times 3 squared. Now, the reason I did that is because I wanted to put that 1 and that 1 together to give me a 2. And then I put together the n and the -1 together to give me this one. So I kind of like moved things around, shuffled things around, kind of reordered that like n-1 + 1 + 1, which is n-1 + 2. And then I broke it into 2 pieces. Now these both have an n-1 on them. And since they both have an n-1, I can rewrite it this way. There's a 2 here. There's a 5 here, that's 10. And on the bottom of 3 squared, that's 9. And then this right here, since they both have a n-1 power, I can write as 2/3 to the n-1. And now this does look like what we needed it to look like. We need it to look like this, AR to the n-1. And this will give us an answer as long as the R is less than 1, the absolute value. And that's our R, that's our A. So this should sum to be A over 1 minus R, which is 2/3. So it should sum to be 10 over 9 minus 1/3. And then I flip 10 over 9 times 3 over 1. And then I can reduce that. 10/3 is the answer. Questions there? The key to this is to get that n-1. If you can get the n-1, then you just need to move things around and then just apply the formula. All right, last one here. Find the sum. So I need a formula first. I need to see if I can write this in a formula. So I'm gonna see here. I've got on the top look like powers of 3, don't they? It's like 3 to the 0 over 5 to the 1 minus 3 to the 1 over 5 squared. And then plus looks like 3 squared over 5 cubed minus 3 to the 3rd over 5 to the 4th. So that looks like I have that pattern happening. It is an alternating series because it goes plus minus, plus minus, plus minus. So I need to rewrite this as -1. I need to start positive. So I'm going to put n-1. And then my 3 needs to start at 0, so n-1 there. And on the bottom, my 5 needs to start at 1, so I'm going to put 5 to the n. Questions on how I got that formula? This makes it alternate starting positive. This gives you 3 raised to the 0, then 3 to the first, then 3 to the second. This gives you 5 raised to the first, then second, then third. So any questions there? What time is it? Okay, good. One more thing, and I can use the formula. I need to change this down here to a -1 + 1. That way I can peel off something and it should, look like the geometric. So I'm going to rewrite this as -1 to the n-1, 3 to the n-1. On the bottom, I have 5 to the n-1 times 5. Peeling off that 1, 5. And then all 3 of these are to the n-1. So I can rewrite this as a 1/5. The 1/5 is from this 5 on the bottom, just slide it out to the front as a 1/5. And then everything else I'm going to put in parentheses together. So I'm putting the -1 and the 3 and the 5 all together in one fraction to give me -3 over 5 to the n-1. There's your A, there's your R. And also notice the absolute value of R here is less than 1. That does check out. Even though it's negative here, when you take the absolute value, it needs to be less than 1 for this formula to work. So it is. So my answer is A, which is 1/5, over 1 minus R, but R this time is negative. This is the first time it's been negative. So we should get 1/5 over 1 + 3/5, which is 1/5. See, we add these together, we need a common denominator. So if you put a common denominator, you should get 8/5. Flip it, you should get 1/8. Is that right? Yeah, 1/8. That's the sum. All right. One more problem. I'll go with this one. It looks worse. All right, so my goal here is to take this, turn it into a matrix. 1, -1, 1, -4, 2, -3, 4, -15, and then 5, 1, -2, and 12. There's my augmented matrix. I think I forgot to put the line there earlier. I'm sorry. And I want to get basically 1s along here, and I want to get 0s down here. I already have a 1 here, so I'm going to first go after this 2 and make it a 0. So I hit the top one with -2. My new system, I'm working fast here. -2, 2, -2, 8. That's me passing a -2 through the top. The next row stays the same. And the last row stays the same. All right, now I add these 2 rows together, and that will become my new second row. In my first row, I'm going to go back to what it was earlier, dividing both everything by -2 to take it back to what it was. Now we get 0 because we add this together. Add this together, we get -1. Add this together, we get 2. Add this together, we get -7. Yeah, -7. And then the last row, 5, 1, -2, and 12. Okay, so I've got a 1 there, 0 here. Let me get a 0 down here for the 5. So I'm going to hit this with -5 up there. So -5, 5, -5, 20, 0, -1, 2, -7, 5, 1, -2, 12. All right, now add these two together, and this will become my new third row, and my first row is going back again to what it started as. Second row is unchanged. Third row is these two added, so I get 0, I get 4 here. 5 and, wait a minute, hold on, I think I just messed that up. 0 and then 5 plus 1, 6, that would have sucked. Okay, and then these two together, I get -7. And then these two together, I get 32. Something's looking really weird here. All right, I've got zeros here. Now I need to get a 0 here. So I'm going to multiply the middle row by 6. That way this will cancel. So now my system looks like this. 1, -1, 1, -4, 0, -6, 12, -42, 0, 6, -732. Now I'm going to add the second and third row together. I'm going to take the second row back to what it was, but I'm actually going to be a little clever here. I'm going to take it back to this, but I'm actually going to multiply by -1 also to make this a +1 right now. So it would be a 1, -2, and then 7 there. I did that instead of leaving it like that. That way I have a 1 here, 1 here. Now I add these two rows together. I should get 0 here, 0 here. Here I get 5. And here I get -10. This is looking promising now. One more thing, divide both of these by 5 or multiply by 1/5. And when I do that, save myself some time, 1 and -2. So now we know, now we got it down to the echelon form, so we can go ahead and start putting things together. Back substitution. This tells me that z is -2. Then I go to this equation, which was x minus, no, not x, sorry, y minus 2z equals 7. I replace the z with -2. This becomes y plus 4 is 7. So y must be 3. Now I know what y is. And then I go to the very first equation, which says that x minus y plus z must be -4. So that means x minus 3 minus 2 must equal -4. This is -5, and if I add 5 to both sides, I get x is 1. So your solution is the ordered triple 1, 3, -2. Okay. That's a lot of work. So that's it. That's the review for the final. I didn't even do it all, right? I skipped a lot, but that just gives you an idea of the types of problems to expect. On the final, here's what I'd like for you to do. The final is, are y'all there? I want to make sure, because I know I would have put I would have put myself to sleep already if I were you. I want to talk about some things for the final. So on the final, 12:30 next Wednesday, please bring your any homework or anything that you've done throughout the semester that you might consider to be like where you have all your work, right? Notes, anything else, bring that with you, okay? Bring it with you to the test. I'll explain how I might use that later, but you need to bring it, all right? Now, if you don't bring it, you won't be penalized, but then you may not benefit from what I'm going to offer, okay? So bring your notes. You can also, for the test, create one reference sheet, 8.5 by 11 sheet of paper, front and back. You can type it up, you can write it, doesn't matter, with any hints, steps, procedures to do anything. You just can't have worked out problems. All right, so we've talked about this, I believe, before. Just don't go take review problems and work them out and say that's your reference sheet. has to be referenced, not copied problems, all right? Now, if you want to use some weird symbolic like thing to like some language only you know, that's fine with me. Just don't have the problems worked out, all right? Any questions on that? You'll be allowed to use that for the test. No?
Will there be any penalties or bonuses to not using one?
Nope, everyone can use one. Yeah, I'm not going to do penalty or reward or anything, just, you know, everyone has the opportunity to use a reference sheet for this test. So, but that also means like during the test, you can't be like, well, hey, you know, I forgot the formula for, you know, what was that property of logs again? I'll be like, you had an opportunity to write things down, so, you know. Anything else?
So at the beginning of the semester, you said that if we turn on our cameras, we'd get like bonus points. Was that a joke or was that serious?
Well, no, that was serious, but everything got so weird, you know, like we went on campus, we stopped, we had to go back on Zoom. Then I went back on campus and a lot of people didn't come back onto Zoom. And then, I mean, look, we're here at the end. We probably have like 8 students in this class still, you know. This has been a bumpy class. So all I'll say is this, just do your best, okay, on the test. And if it comes down to, you know, we're talking about a point or two between a letter grade, I'll look at, you know, did you attend? You know, were you there? And I know who's been there. I mean, most of you have. So, you know, I will reward you for attendance, period. All right. Just focus on being prepared for this test, because, you know, it is a decent percentage of your grade, right? It's not everything, but it is a decent percent. So, any other questions? Okay, we'll call it a day. If you need me between now and next Wednesday, you know, just text me. Of course, my number's on the syllabus. You can text me. If you're working on something, you're having trouble, you know, just reach out, okay? I don't want you to feel like there's no help available to you. And good luck on all of your finals and preparing for all your finals. I will see you on campus next week at 12:30.
Yeah.
Okay, everyone take care.
Thank
Sir.
you.
Thank you.
Sir, I had a quick question, not related with the